So this is my first time doing this without the headset. New microphone. Let's see how it goes. In last week's videos, we learned that in order to find the length of an arc, okay, so let's call that, I don't know, let's call the length L, right? And we found out that that length is the angle you've got in degrees divided by 360 degrees, and you multiply that by 2 pi r, right? R being the radius, and theta being the central angle, the measure of the arc. So that's the old way of doing things, but mathematicians are always searching for a faster, more efficient way to do things with fewer steps and less confusion. I know that seems weird, but it's true. So how do we simplify this process? How do we make finding the length of an arc, which can be a very important thing, a very important technique, how do we make it as simple and as easy and as streamlined as we can? And the answer lies in changing this. It's that 360 degrees. Why are there 360 degrees in a circle? Ask yourself this question. Why is it that a circle has 360 degrees in it? Now, the answer to that is complicated and involves a lot of history, but the short answer is we made it up. We, being human beings, decided at some point that we were going to take a circle and split it into 360 separate parts and use that as our unit for angles. But it doesn't have to be that way. And we can set a new unit to make our life more convenient. So let me erase this. Now, let's think like a mathematician for a moment, okay? We have this problem. We need to find the length from A to B along that arc. But we don't want to have to, every single time, find the angle in degrees, divide that by 360, then multiply that by 2 times pi times the radius. It's a lot of steps. So we want to change that. The 2 pi r isn't going anywhere, right? That's still the circumference of the circle. It's not going anywhere. Now, what number should we put under here if not 360? If theta is going to be in some other unit that isn't degrees, we get to choose how many of that unit fills up an entire circle. So what mathematicians very cleverly decided to do was take this denominator and make it 2 pi. This has a couple of implications, okay? First off, there are 360 degrees in a circle. There are 2 pi radians in a circle. So instead of dividing by 360 degrees, which is the number of degrees in a whole circle, to find the arc length, we instead divide by 2 pi, which is the number of radians that are in an entire circle, okay? 2 pi is about 6.3, right? A little bit less than 6.3. There are that many radians in an entire circle, and I'll show you why in a little bit, but for now I want you to see how useful this is, because look at this equation. Look at what we've done. We now have a 2 pi on the top and a 2 pi on the bottom. That's why we chose 2 pi to be the total amount of radians in a circle, because look at how awesome this becomes. Instead of taking your value in degrees and dividing it by 360 and then multiplying by 2 pi and then multiplying by the radius, you now are taking your angle in radians, dividing by 2 pi, because there are 2 pi radians in a circle, and then multiplying by 2 pi. So no matter what the angle is, the 2 pi and the 2 pi will cancel out. So we're left with length is angle in radians times the radius. So I'll let you decide which of these two formulas, which of these two units you think is more convenient and easier to use, but you're going to have to be fluent with both. So here we've got a circle that has a radius of 5 inches and an angle measure of 1 radian. Okay, so the length of this arc, again, since we're dealing with radians, we just have to take the radius and multiply it by the angle in radians. It's 5 inches. That's a times, not a decimal. It's 5 times 1. If this was 2 radians, then the length of the arc would be 5 inches times 2 would be 10 inches. I hope you can see how this process is arithmetically much simpler. So let's get to the meat of this, which is converting between degrees and radians, right? If you are an American who uses feet and you are going to be working with a European who uses meters, one of you is going to have to convert your units into the other unit in order to be able to have a conversation. So we're going to do that. Sometimes a problem will give you a angle in degrees, and it will be advantageous for you to change it into radians before working with it, or vice versa. So we said that a whole circle is 360 degrees, right? But we also know that a whole circle, well, we just came up with how many radians there are in a circle. There's 2 pi of them. I'm going to use RAD for radians, just like your calculator. So it shouldn't be too big of a leap to see that 360 degrees and 2 pi radians are the same value, right? They're both a complete circle. So we can say that 360 degrees equals 2 pi radians. Yeah? Dividing both sides by 2, we can say that pi radians equals 180 degrees, and that's going to be our unit conversion. Okay, that's going to be our conversion factor. That's how we're going to get from degrees to radians and from radians back to degrees. For example, convert 150 degrees to radians. Okay, well, it's been a while since many of you have done unit conversion, but let's go ahead and give it a shot. We've got 150 degrees, and we're going to multiply that by some fraction that doesn't actually change the value of things, right? We did this earlier this year. We know that there are pi radians in 180 degrees. This fraction here that I just made is actually equal to 1 because those are 2 equivalent values, right? Pi radians and 180 degrees are the same value, so their quotient is 1. So we're not actually changing the value, we're just changing the units. Now, I put the radians on top and the degrees on the bottom because now I've got degrees on top, degrees on the bottom, so the degrees cancel, and I'm left with 150 pi divided by 180. Okay, well, those are both divisible by 10, so I get 15 pi over 18. 15 and 8 are both divisible by 3, so I get 15 divided by 3 is 5, and 18 divided by 3 is 6, so I get 5 pi over 6 as my final answer. 150 degrees is equivalent to 5 pi over 6 radians. Again, I know it seems weird to get pi involved, but once you start solving for arc length, the pi's tend to cancel out. Not always, but they tend to cancel out. All right, let's do another example. Example 2. Convert 3 pi over 4 radians to degrees. Okay, well, I can think of 2 ways of doing this. I will show you both. Okay? Since there is a pi in here, there isn't always going to be a pi in here, but because there is a pi, we know that pi radians is equal to 180 degrees. We can just do a substitution. We can say that this is 3 times 180 degrees over 4, and then we can go from there. Okay? So anytime you're converting radians to degrees, if there is a pi in the radians, you can just take out the pi and substitute in 180 degrees. That will work. But I'm going to go ahead and do this the proportions way. Anyway, so we have 3 pi over 4 radians. Remember, radians are on the top of that fraction, right? So again, we're going to multiply by our scale factor, but since we have radians on the top, instead of instead of pi over 180, we're going to put the degrees on the top and the pi radians on the bottom, right? Because now the radians on the top and the radians on the bottom cancel, and we are left with degrees. Okay? And hey, look, conveniently enough, the pi also cancels, just like I said it probably would. So the pi goes away, and we're left with 3 times 180 divided by 4. Well, I happen to know that 180 divided by 4 is 45, times 3 is 120, 135 degrees. So that's the basics of radians. Now, I will release a couple more videos getting more into depth about this. If you are confused about what radians are and where the hell pi came from and why we're doing all of this, that's okay. I have more videos coming that will explain more, but this video was intended to be a very, very quick, very surface level look at what radians are, where they come from, and why they're useful. So if you're still having a hard time, just look forward to the next video. Ask questions that you've got down in the comment bit, or you can email them to me, or you can put them on Google Classroom, or you can show up to a Zoom meeting. The point is, you've got a lot of options if you're confused. I hope this went well. I hope you're doing well. Happy Monday, and I will see you next time.